Hello, my name is Pappy Bedard, and I'm a retired engineer who decided to learn Cinema 4D as a hobby. I've learned a lot on YouTube videos. Lots of great people out there give free tutorials, and I thought it's time for me to give back a little bit by doing my own tutorial. This one involves the Formula Spline. And what it does is it encapsulates the math used in spirograph patterns to create these spirally lines. Now, I'm going to show you how to create a rig that will create things like this. I'm going to be using a little bit of Python and a little bit of Expresso. For those of you who may be unfamiliar, a spirograph is a kid's craft toy. It includes a ring that you fasten to the paper, and then circles with holes in them that you use to roll around either the inside or the outside of that ring to trace beautiful spiraled patterns. Now, there's a math behind all of this. And if you look at Wikipedia, for example, you will find that that's as simple as that. Now, I'm not going to get into all that in math other than to say that I've boiled it down to the X and Y values for every point on those curves. And those can be plugged directly into the Formula Spline. And that's what I'm going to show you. So the way it works is, I'll show you here. You start with a circle fastened to the paper. And inside or outside of that circle, you roll a smaller circle and put a pencil in the hole so that as the circle rolls around either inside or outside, it traces a pattern like this. Now that's what it looks like if you're rolling inside of the hole, and this is what it looks like if you're rolling outside the hole. So first, let's take another look at those equations. I'm going to hit Control Tab here. So now, let's call the static circle, the one that's fixed in the middle. The radius of that, we'll call it S. The radius of the rolling circle, we'll call it R. And the radius from the center of the rolling circle out to the hole where the pencil goes is H. So this is the equations from the websites. You could easily Google this stuff. So the trick was to fill in the values you want for S, R, and H in order to have something that looks like this. In this case, the static circle radius is 200. The rolling circle radius is 60, and the radius out to the hole is 38. Now the t in this equation relates to the number of degrees you've traveled around the fixed circle. So if we plug these two equations into our Formula Spline, then we should get that shape. So let's do that. Control Tab. So I'm going to create a brand new project. So just so you know, I've turned off the grid, the horizon, the world axis, and certain things so that they wouldn't distract us from just looking at the pure shape of the spline. So we will start by creating a formula spline, which comes already pre-supplied with a formula. Now you see this XT and YT, and ZT and various parameters here. These are the things we need to fill in. So I've actually already got these X and Y equations I showed you earlier ready to cut and paste here. So I'm going to paste in the XT. That's the one we just talked about. And I'm going to copy and paste the YT. And let's see what we have now. Well, it doesn't look very good, does it? So let's, oh, I see the problem is that it only goes from T from -1 to 1. We need to boost this way up. Okay, we're starting to get something that looks like it, but what is going on here? Well, the reason it looks like this is we're not sampling enough points. So I need to raise this up. So I'm up about 360 here, and it's starting to look pretty good. But I know from experience in dealing with a lot of examples here that this samples, we may as well set it to a very high number now. I'm going to set it to 2 million. Okay, the other thing I'd like to do is set cubic interpolation, because that makes it look a little smoother. So there we go. Now, this is all very nice. The problem is if you wanted to change this to a different radius for the fixed circle, or a different radius for the rolling circle, or a different place for the hole where the pencil goes, then you've got to search through these equations and make those modifications. Wouldn't it be nice if we could take add some new controls that makes it a lot easier to set those values? Well, that's what we're going to do next, using a combination of user data, Xpresso, and yes, even a little bit of Python. Okay, so down here in the Attribute Manager, there is a tab called User Data. We're going to click on that and Manage User Data. This allows us to create our own data that we can use later in Xpresso or other places. So I'm going to start by adding a group, then pull it out of that default group. And I'm going to rename that to parameters. And I'm going to give it 2 columns just to save a little bit of space. Now I'm going to add some data. So the first parameter we want to have is the static circle radius. And I want that to be a float, and we want the interface to be a float, and the units are to be real numbers. And 0 to 1,000 is fine. We're going to add another data. Let's see what's happening here. The other parameter we want is a rolling circle radius. And same thing here, we're going to make that a real number, but in this case I'm going to give it allow for a -1,000 up to 1,000 radius, and that will become clear later as we get into this. We'll add some more data. This time I want the radius out to the hole. Again, it's a float, real number, and I also want to make this allowable both plus and minus. So, well, let's stop with just that for now. So we hit OK. Now you could see that there's another tab here. So I'm clicked on the Formula Spline. We have basic coordinate object like usual, but now we have this other tab called Parameters. That's the one we just created. So now we can set some values in here. Let's put in the ones we've been using. 200, what was it, 60, and 38. So now the trick is, how do we use these values to generate this text so that when we change them, this text will automatically get updated. Well, to do that, we need some Expresso. Okay, so right here on this Formula Spline object, we are going to add a tag, a Cinema 4D tag, Expresso. And that opens up the Expresso Editor. So here's where the magic happens. I'm going to take this object, this formula, and drag it in here twice, because I want to take some values from our user data to set other values in the object data. So what do we have here? So let's, all right, from formula, we want to go to our parameters. Remember, that's what we call that group. We got the radius, static circle radius. I'm clicking on this little pink corner here that allows you to add properties. Back to parameters, we want the rolling circle radius. And finally, parameters, we want the radius to hole. Now I'm going to stretch this out so we can see them. Now these become outputs that we could plug into somewhere else. Well, where do we want to plug them? Well, back to this formula object, let's look at the object properties. We want to be able to set xt, and we want to set yt, and we want to set, well, we're probably going to have to set TMax, and I'll get into that in a minute. Okay, so we can't just simply plug our circle radius into xt, because the circle radius, the static circle radius, is just 200. We can't put a 200 there. What we have to put there is that crazy formula. And this has to be text. Over on this side, on the output of formula, this is a real number. See, it says there real. This one is a string. So somehow we got to get this real number and this number and this number and build a string and plug it into there. Well, to do that, we are going to create an Expresso script Python node. Now it comes with some defaults here. The output node by default on a Python script node is a real, I don't want that. I'm going to delete that port. I'm going to create a new one, and it's going to be a string. And I'm going to right click on it and rename it to, oh, let's see, I guess I could call it XT. Just so we know what we're dealing with. All right, I'm going to need another string for YT. So I'm clicking in the pink area. I want a string. I'm going to right click on it and rename it to YT. So I've got those two done. Now TMax, that's a number. So we're going to have a real number here, a float, and we're going to call that TMax. Okay. So over here on this side, I have inputs. They're numbers already. You see, if I hover over it, it says it's a real number. That's what I want. I want that one to be a real number, but I don't want to name this. So I'm going to rename this one. I'll just call it S for static circle radius. I'm going to call this one R for rolling circle radius, and we need another one. So I got to click up here in this blue corner, and we need another float, And I'm going to rename that one H for radius to hole. So now we can connect these. So we're going to take the number in our user data and plug it into this Python script here. You just drag between these two circles to connect them. All right, so those three are connected. And then eventually these three coming out of here will connect to these three things to set the object parameters for that formula. Let me click on formula here. I'll show you what I mean. See, this is the object tab, and XT and YT are going to have to be plugged in here. And TMax is this value down here, which we had, remember we had to increase that so we would see more than just a slight portion of the curve. Turns out that that number has to be quite large for complicated patterns. And it's always variable. So I'm going to calculate what that number is, and we're going to plug that in. All right, let's click on the Python node, and click on node over here, and we see a little bit of Python code over here, but it's definitely not what we want. So to make this a little easier to see, I'm going to click on this button down here that says Open Python Editor. And all it does is open that same thing, but in another screen. It says, Welcome to the world of Python. Well, thank you. So this little pound sign at the beginning of the text here, that just means it's a comment. That's not actual code. So anytime you want to just annotate what you're writing, you can put a little pound sign in front of the text. In fact, we could just change that to Spirograph. There we go. Now, we have a very simple little bit of Python script here. So global is a declaration of variables that can be output from this node. And you see XT, it put that one in automatically, but it didn't put YT or TMax. So we're going to add those, YT and TMax. Now the input nodes, S, R, and H, are actually variables we can use in here. I don't need this equation. So we're going to make different equations. So let's see. The distance to the hole is H. Well, what's the formula we need? Well, going back to the websites, we could see that the formula looks like this. So it's kind of what we want, but the problem is this would give us actually take these numbers and calculate a value for X. It would still be a number. I don't want that. I'm just going to turn this into a comment just for reference. And in the interest of time, I am going to show you what we are going to do here. Eventually, we have to come up with this. Let me go through it a little bit. You see this S minus R here? This is string of S minus string of R. The trick here is we want to replace. Here, let me just show you a little bit of this. So let's say I started here and I wanted to replace that. Well, it starts with a, strings, by the way, are always in quotes. So it starts with an open parenthesis. Now we want the value S. I can't just put S in there because S is a number. I have to add it to the string, but convert it to a string like this. Now the next part is a minus sign. So I need to add a minus sign. Now I need to put the value of R converted to a string. So I'm going to put that. and then continue on. So you see what's happening here. I'm building this up exactly the way it shows here below. I will let you study that on your own. The idea is we want to build a string substituting these values of S, R, R, S, and H to the S, R's, and H that are being fed into this Python script. So we have the same deal for YT. So what we're doing here is we're saying that the value of XT output from this script is going to be this string. And the value of YT output from this script is going to be this string. And for now, let's just set TMax to be a big number. Say 1,000. So TMax equals 1,000. Now that number can be tweaked a little bit later, but let's just see if this works. I'm going to close this and go click on, close this thing here too. Go to Formula. I'm going to open this up a little bit here. See if I can get both parameters and object on the same page here. Okay, fine. So down at the bottom here, you can see parameters. By the way, what I did is shift click so I can see both the object tab and the parameters tab at the same time. So above here, we see the parameters. These are the numbers we had typed in before, or pasted in. And these are the numbers down here. So let me just try changing the rolling circle. Well, nothing's happening. Well, this is where debugging comes in. Okay, so to debug a Python script, we have to go up to the script menu and open up the console and then click on Python. Let's open this up a little bit and let's scroll all the way to the bottom and see what the problem is. Oh, it says here the global name toHole is not defined. Where is toHole? All right, go back into my Python script. Open the Python editor. Do I have, oh, I have toHole as a variable in here. I forgot to tell you about that. The distance to the hole. All right, right now that's just H. So in other words, we have an internal variable I've defined called toHole, and right now it's going to be H, which is, let me move this over. This H right here, the radius to the hole. Now I could have just used H in there, but I want sometimes for it to be calculated. So I'm going to create this internal variable called toHole, start out by setting it to H. And I'll enhance that in a little while. You'll see why. All right, so let's try it again now. Click on the formula. Now I'll change, oh, it's already working. So I'm changing the radius of the rolling circle. And you see what it's doing there. I'll change the distance to the hole. It's doing this. That's pretty cool. So this seems to be working good for a lot of these values, but some of them it doesn't seem to be so good. Like this one here. When the rolling circle radius is 37, it looks like TMax is not quite large enough to include all of the loops we need. So what I'm going to do there is add a calculation for TMax. Now I'm not going to get into exactly what all the math is about here, but I'm just going to go ahead and enter it and explain it as I go along. So I'm going to go ahead and open the Python editor. So double click on Xpresso, click on the Python node, open the Python editor. Now TMax here is set to 1,000. That is not what we want. We want it to be variable depending on the correct equation. Now what the correct equation is the radius of the static circle times 2 times pi divided by the greatest common denominator. What that is the largest number that will evenly divide into both S and R. Don't ask me to explain that. I found it online. So we need D to be the greatest common divisor. So I'm going to set D equal to greatest common divisor of S and R. Well, it turns out there is no function called GCD. I had to look that one up. So the easiest way is to use Google. So I went into Google and I just searched for GCD in Python. And I could cut and paste the exact code I needed to give me the GCD. So I already have it here. I'm just going to copy it from a different screen here and paste it in here. Oh, looks like I already did. So this line right here defines the main function or the main routine. This defines the GCD routine. So here I'm calling it. One thing I know I'm going to have to do is take the absolute value of that because I always want it to be positive. So I just surrounded that with another function, ABS. Okay, let's give that a shot. So what we should see is the TMax value change now, depending on what number we pick for the radiuses. Well, it didn't change. So let's go into the script console, go to the Python section, and it says the global name pi is not defined. Oh, that's because pi is a mathematical term and that exists in the math module. Double click on the Expresso tag, click on Python, open in the editor, and right up here we have import C4D. That imports functions related to C4D. We need to import another module called math. And then we need to tell pi where pi is. It's in, we just can't say pi. We got to say where pi is. It's in the math module. Math module.pi. So now let's see if this works. Close this. Go back to click on formula. Okay, I can see that now, see the 37 here, rolling circle, but now TMax is 1256.637. And as I change this, the value of TMax, well, keep an eye on TMax. See, it's changing depending on the ratio of these two circles. The number of times you have to loop around to end up where you started is related to that formula. So now this is complete. I could change the outside, the large side. One thing I want to show you here. So let me go back to our original values, 200, 38, and 60. So that's the curve we got. What if we change this to minus 60? Well, now we're rolling the rolling circle around the outside instead of the inside. So it gives us a different pattern. Now, with that in mind, I'm going to go back to the original project where I've added a couple of bells and whistles and talk about that. Okay, so I already have that project open. I'm just going to go to it. It's this one here. And, well, this is the one where I showed you the pencil actually drawing the shapes. Let me hide this animation thing here. I'm holding Alt to turn both of those off. And I guess what I'll do is I'll turn on this. And what I did is I just added a simple circle spline to represent the large or the static circle. I added a rolling circle, which represents the circle that rolls around. And I added a whole circle. And I controlled their positions using the same Python script. Here I'm just grabbing the radiuses and changing the positions and locations of these circles based on what radiuses are chosen. Now, I've also added a few extra variables in the Python script here. One called two-hole. Well, I got one called, well, let me just start here a little bit. Let me go back to Formula and show you what parameters I have set here. I'm just going to click on parameters. So what I did is I added a checkbox called hole at rolling radius. When that's checked, it makes the radius to the hole equal to the rolling circle radius. Let me put these values back to what we were just looking at. So this is what it looks like when it's 200, 60, and 38. If I click hole at rolling circle, it just puts the hole right at the very place where it puts it right on the radius of the small circle. And no matter what you change this to, it's going to stay there. And this can no longer change. You can try to change it, but it won't change. I also added two static strings here. I think that's what they're called. Because I wanted to know how many points I had and what was that greatest common divisor. I was just curious. So let me just show you. If I go into user data, manage user data. So I added points, which is simply a static text. And I added GCD, again, static text. I did not make them animatable. And hole at rolling radius, I made that a Boolean. It's just a true or false. In other words, a checkbox. So now let me go into the Python script and show you what that looks like. So click here, go into the Python editor. Well, I added a bunch of comments in here too because I am going to include this project as a download for you guys. So remember I set two-hole to H, and I said that'll be good for now. Well, I created this Boolean variable called same. See it here under the Python? So whatever hole at rolling radius is pumped into same. So in other words, that's a true or false. So same is a true or false. So here I'm saying if same is true, then make two-hole equal to R, which is the radius of the rolling circle. So it's either H, which is the value you set, or R, if that's checked. What else did I do? All I did was I created two more outputs called points, actually three more, points, two-hole, and GCD. So I put them in the global declaration up here so that we could use them outside of the Python script. And I set points to the string version of that and GCD to the string version of that. And the reason I did that is so that I could pump those into let me go back to Formula here. I'll show you. So Formula points is this user variable. So I'm putting the value of points in there, and I'm putting the value of GCD in here. And if this is checked, it changes the radius to hole to the same value. So that's why I output that. So these radius to hole, actually right there, you can see that's the name of it. So radius to hole, points, and GCD, these three things are set automatically. So if we take a look at this now, so I can change this value. if I uncheck this, I can change this value. And I like the little yellow circles there. It gives you an indication of what the spirograph actually might have looked like. Now in a real spirograph, this hole has to be on this little circle. But in this Cinema 4D spirograph, you can put the hole outside the circle, which is kind of impossible, but it kind of makes some nicer patterns. Now the last thing I wanted to show you is well, what I did is I created a sweep. I named it Spirograph with params. I gave it a nice shiny silver material. And then I have this end side, which is just a four-sided closed spline that I swept along. So if I check this, you can see now I can give it a nice looking material. Now, by the way, this all still works. I can go ahead and hide these things for now. And so what I can do is click on Formula, and I can change this, and I can get any kind of cool patterns. Change the radius here. Pretty cool, huh? Now I'm going to turn that off for a second. The last thing I want to do is show you that you can click on Formula here. It's got everything tied to it, all of this scripting and this Expresso. And you could say File, Save Object Preset. And I'm just going to call it Spirograph Formula. All right, now what that did, I'll create a brand new project here to show you. Brand new project, new. So it's just empty. I'm going to go to my content browser and search in the show you some. In the user area under objects, we now have this Spirograph formula. That's the one I just saved. Double click on that and it brings it right into your project. I'm going to click on it again and maybe a third time. So we actually have 3 of these now. Let me go back to the object browser here. You see I've got 3 of them. Each one of them has its own scripting attached to it. So I'm going to take the first one, change the radius of the hole to slightly smaller, and the second one and change it to slightly bigger. And so you can get some really interesting looking patterns here by stacking these up, exactly like a real spirograph. You can change their colors, you could sweep stuff along them. You can even subject them to different deformers to wrap them around things or whatever. So finally, I just want to show you the original here that I had shown at the beginning of this tutorial. Right here. So here I've just used 3 of those objects that I saved to the content browser, and I swept them all, and I made this cool shape. And again, this is all completely parameterized, if that's a word. So I could take this middle one, change it to a different radius. You could see that I can modify this on the fly. Now, what could you do with something like this? Well, you can make some cool medallions, maybe some appliques on different, furniture or whatever. Or you could actually probably turn it into a fancy window frame and put it on a building. So, so that's about it. I hope you enjoyed it. If you do, consider liking and subscribing. I'm going to continue to do these sorts of tutorials, and I appreciate you sticking with me. Oh, by the way, take a look down in the description, and I will include a link to this project here that we're looking at. Well, actually, to this project. I'll include a link to this, and you can see how all of this stuff is tied together and take a closer look at at the Expresso. And anyways, happy C4D, and I'll see you next time. Thank you.